So I took 46 plus 102, subtracted it from 180, and I got 32 degrees, and then you do the angle opposite, or the side opposite from the angle, so CB would be the smallest angle, AB would be the second smallest, and CA would be the largest.
Thank you. Abby, tell us, do you agree or disagree?
I agree.
Yeah, very good. So first you have to find the missing angle, and then the smallest side is opposite the smallest angle. And since A is the smallest angle, CB would be the smallest side. And since B is the biggest angle, CA would be the biggest side. Okay, perfect. What questions do you have on the bell ringer? All right, for yesterday's bell ringer, you had to order the sides from smallest to largest. 80 plus 45 is 125. So I believe you should have gotten 55 for this angle down here, angle A. And then for the smallest side, it would have been AB, and then BC, and then AC. So you would have gotten AB, BC, AC for yesterday's bell ringer. All right, what about your 9.1 worksheet? Or just over 9.1 in general, the triangle inequality theorems? Yes, ma'am.
How do you do number 4?
Is that the one with the exterior angle?
Yeah.
Okay, yep, that was the one that quite a few people, or I would say the most common missed question. Okay, so it has a triangle, and then it has this side here extended, and it has that one as 115 degrees. This one down here, was it 52 degrees?
Yeah.
And let me see the
I think it's supposed to be 6.
A, B, C, D. So here's A, B, C, D. And you were supposed to list the sides in order from smallest to largest. Well, you got to find all the angles. It only gave you one interior angle, but it did give you this exterior angle. So two things you can look at. These two are a linear pair, so they add up to 180. So you do 180 minus 115, and you get 65. And then you can add these two together and subtract it from 180, and you get this one to be 63. Or you could have just done 115 minus 52 and got 63. Now you don't even care about this part right here anymore. Now you're just looking at triangle BCD. 52 is the smallest angle, so BC would be the smallest side. Then it goes 63, so BD would be the next smallest, and the largest side would be CD. But you had to use what we talked about with exterior angle, and linear pairs in order to find these two angles. What other questions do you have on the worksheet? What about section 9.1? All right, let's go ahead and close our Chromebooks. All right, you can go ahead and put those away. You need to get out your notes that I just gave you, 9.2. Good morning.
I think I'm supposed to be heading over to help carpentry from DEC. I'm not got the list or something. I saw all the guys from the last couple of years.
All right, so previously we talked about inequalities in one triangle. Now we're going to talk about inequalities in two triangles. And it says students will be able to compare measures in triangles. And students will be able to solve real-life problems using the hinge theorem. Okay, so the hinge theorem. And I'm going to use an example, and it's going to be the door. have, let's just make a triangle. So the 3 points are from the corner of the door to this wall, and then the other, and then to the edge of the door. Okay? And the angle we're looking at is the angle that the door makes when you open it. Okay? Now, and then we're going to compare that angle with the distance here. Okay? Let's say that that's 5 feet. If I made this angle bigger, say right there, do you think the distance is going to get bigger, stay the same, or be smaller? Bigger. So if the angle's bigger, as long as you keep the other two sides the same, if this angle gets bigger, the distance between these 2 points get bigger. Okay? And you can do that to compare triangles. So like, let's say you have 2 different triangles. I have 2 different doors. I have this door opened up that far. And these doors are the same. Can y'all see this door here? Okay. Let's get off our seats for a second, so that way we can compare the 2 doors. And let's go out in the hallway. Alright, so I'm gonna open this door up to a 90-degree angle. So it would be right there at a 90-degree angle. And you're comparing the distance from the door to the wall. And here, the same distance. Okay, notice the 2 sides are still the same. This side, the doors are the same length, and the doorway is the same length. The only thing that's changed is that angle. Which of these has a greater distance away from the wall? That one or this one? Yeah, that one, because it has a 90-degree angle. This one has one of a 45, 50-degree angle. So the bigger the angle, the bigger the side. And you can compare 2 triangles like that. Okay? Alright, let's go back inside.
He might already be in the BDC.
Okay, you
Can
can,
I go down to culture?
yeah, you can go ahead and go.
No, you guys. Wait,
Alright.
who's in your class?
So notice it says the hinge theorem, and to me it's really easy to remember the hinge theorem because a door hinge, okay, and that helps me remember it. The door hinge, you know, it's where the door turns. It's what helps the door turn right there, the hinges on the door. So that helps me remember what the theorem says. It says that 2 sides of one triangle are congruent to 2 sides of another triangle, and the included angle of the first one is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. Okay. Alright, so I have an example. Notice, whenever you look at this, see how VX is marked congruent to RT and VW is marked congruent to RS? So those are the 2 sides that are congruent. Well, the included angle between RT and RS is R, and the included angle between VX and VW is V. R is 35 and V is 88. Okay, so notice that V is bigger than R. Okay, well, since V is bigger than R, then that means that this side here is going to be longer, and this side over here will be shorter. Okay, so that means that the length of XW is going to be greater than the length of TS. So XW is going to be longer than TS, and that's because V is bigger than R. So I like this angle here, like this angle would be where your door hinges are. This door is opened up to almost a 90-degree angle. This door is only opened up to a 35-degree angle. So this doorway would be wider than this doorway. Alright, look at the converse of the hinge theorem. It says if two sides of one triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. It's the exact same thing, just backwards. It's saying if you know that the two distances of the from the door to the doorway is longer, then you know that the door is opened up wider, at a wider angle. All right, and an example. Notice that CB is congruent to FE and CA is congruent to FD. But this side here is bigger than this side over here. So that means this included angle, which would be C is included between CB and CA, would be the bigger angle, and angle F would be the smaller angle. So we would put that the measure of angle C is greater than the measure of angle F. So now instead of comparing each of the angles in one triangle, you're comparing two triangles in two angles in two different triangles. Alright, before I move on to an example, what questions do you have for me so far? Using the converse of the hinge theorem, notice I whited out the numbers, so you need to put the numbers on there first. It says, given that ST is congruent to PR, how does the measure of angle PST compare to the measure of angle SPR? Okay, so I notice these two sides are marked congruent, and I notice that PT is 24 inches and RS is 23 inches. Well, in the notes it said it had to have two sides congruent. Yep, this side here, PS, is congruent to itself. Okay. So the included angle between these two sides would be angle RPS or SPR. That's angle SPR. And the included angle over here is angle PST. So those are the two angles I'm comparing. Okay. Well, if you look at the opposite side, see how this one's 24 and this one over here is 23? 24 is greater than 23, so this one's the bigger number. So if this one's the bigger number, then that means this angle's the bigger angle. So we would say that the measure of angle PST is greater than the measure of angle SPR. Okay. And if you can't remember like which symbols are greater than or less than, you're welcome to write it out in words.
Apparently, they all met up this morning. We have to wait for our hour.
Alright, let's do one together. It says, given that segment JK is congruent to LK, how does the length of JM compare to the length of LM? So first thing you want to see is if they have any sides that you can mark congruent that's not already marked. Abby, would you say, is there a side that I can mark congruent?
The middle side,
Yeah, I can mark it congruent to itself.
this is for your own tower.
Okay, thank you. Alright, so now it wants us to compare JM to LM, so you gotta pick out which two segments those are. So here's JM and here's LM, so I'm comparing those two. So in order to compare those, you wanna look at their angles, the included angle. Bailey, what do you notice about the angles? The included angle. So between these two sides, K would be the included angle, in between these two sides here that are congruent, that one, MKL would also be included. So what do you notice about those? What does congruent mean?
They're like the same.
They're the same? Okay, so this one's 64 degrees and this one's 61 degrees. Are those the same? No, so they can't be congruent if they're not the same measure. So what do you notice about this angle and this angle?
One's larger than the other.
Which one's larger?
65.
Yeah, this one here is bigger. This is your bigger angle. Okay? All right, so since this one's your bigger angle, Natalie S., which side would be my bigger side? Say that again. That would be an angle, JKM. What side would be bigger? Yeah, the JM would be bigger. Okay, so that means that the length of JM is greater than the length of LM. Alright, let's look at this one here. Notice some of the stuff I've whited out so that way, keep people from working ahead. It says the length of PR is equal to the length of PS, and the measure of angle QPR is greater than the measure of angle QPS. Which is longer, SQ or RQ? Alright, so it says angle QPR. So you need to figure out which angle is angle QPR. Well, we're looking at triangle QPR, and since P is in the middle, it's angle P in the triangle QPR. So that's this angle right here. And then in your other triangle, it's QPS, so triangle QPS, and P's in the middle, so they're talking about this angle. And they said that QPR is bigger, so this angle here is bigger. So they're wanting us to compare SQ and RQ. SQ is this side, RQ is this side. So which one's bigger? Maddie, which side would you say is bigger, SQ or RQ?
RQ.
And why is that?
Wait, how'd you know it was bigger?
She's about to answer it. I don't know. I just.
Oh.
Well, because you're saying because this angle's bigger? Yeah, because this angle's bigger. If this angle's bigger, then that makes this side bigger.
How'd you know the angle was bigger?
It told you on the
Okay.
board.
Well, look, did you put in the little
Did
one
you-
thing?
Yeah, I wanted the greater than sign out, so you had to fill that in. Alright, your next problem is guided practice, so you'll do this one with your partner. So you'll need to fill in that sign. It says if PR equals PS and RQ is less than SQ, which is larger, angle RPQ or angle SPQ? Once you get that filled in, go ahead, face your partner. Bailey, I want to have you work with Nick and Lakin. Grace, what did you and your partner say?
Angle SPQ is larger than RPQ.
So angle SPQ is larger than angle RPQ? How come?
Because the one SQ is bigger than RQ.
Okay, so SQ is the bigger one because if you look here, the mouth is opened up toward SQ, so that makes SQ the bigger. So since SQ is the bigger one, then that means this angle is bigger, which is angle SPQ. And so notice, make sure and pay attention if they're asking you to compare them or if they're asking you which one's larger. If they're asking you which one's larger or which one's smaller, then you just give an angle. But if they ask you to compare it, then that's whenever you say that angle RPQ is bigger than the measure of angle, the measure of angle SPQ is greater than the measure of angle RPQ. Okay, all right, awesome. Let's do another one. Complete this statement with less than, greater than, or equal to, and explain your reasoning. The measure of angle 1 is blank to the measure of angle 2. You're going to either use less than, greater than, or equal to fill in the statement, and you have to explain why. Make sure you explain why. Alright, Taylor, what did you and your partner, which sign did y'all fill in? Less than, greater than, or equal to? How come they would be equal to each other?
Because all sides are congruent,
How do you know that all sides are congruent?
because they have the line from them.
Oh, the reflexive property, this line here? Yeah, so this line would be congruent. So since all three sides are congruent, then that makes the two triangles congruent. So angle would be congruent to angle 2. Okay. And I saw quite a few different answers. Some people said side, 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 completely okay. Some people said all sides are congruent, so that's also fine. Just any type of explanation explaining why angles 1 and 2 would be equal to each other. All right, what questions do you have on 9.2? All right, I believe that makes the page 9.1 is page 40 in your notes, supposed to be page 40. This is supposed to be page 41. And it's 9.2 inequalities in two triangles.
I got 42.
Well, that's because I had made a mistake before. But if you have it as page 42, that's fine. If you just wanted to pretty much just start fresh at 41 with 9.1 and 42 with 9.2, that's okay. Like, I'm not gonna look at the page numbers. Alright, so you have a homework assignment, but you get to get started on it a little bit early since we finished our notes a little bit early. Your homework assignment, which like I said, you have about 20 minutes to 15 minutes to work on it now. It's already posted to Google Classroom. What do you pay for that? Well, I thought it was posted to Google Classroom. I guess it didn't. All right, so since it's not posted to Google Classroom, you could do paper. I would say the best way, because sometimes they just give it to you in words. So you may want to just draw the triangles on your own and label them. It makes it easier, but you're not required to. But your assignment is on Boom Cards. So if you go to boomlearning.com.
It's not in Classroom?
Yeah, it's not in Classroom. It was supposed to share to Google Classroom, but it did not. Alright, so your assignment is the Geometry Triangle Inequalities 20 digital cards. Okay, so you will be working on that for the rest of class. Like I said, it's your homework assignment, but you just get class time to work on it. That way, in case you have any questions. And it'll be due tomorrow at the beginning of class, the triangle inequalities. And then tomorrow we will have an assignment on Big Ideas Math. So if you will not be in here tomorrow due to prom, you will need to do that 9.2 practice on Big Ideas Math by Monday.